On 3.6, we're continuing our goal in finding x-intercepts, but this time we're going to be using factoring. And we have done quite a bit of factoring, so hopefully this will come back pretty easily. But first I want to ask this first question. So suppose we have two quantities, x and y, so just random quantities, and then we multiply them, they have a product of 0, or in other words, x times y equals 0. So write down a list of possible combinations of numbers for x and y that would make that true. So for example, I could say 4 times 0 would work because 4 times 0 equals 0. And maybe you can think of some more examples. 0 times 10. 0 times -3. Or we could do 1,000, 10,000 times 0 equals 0. All of these, when you multiply them together, equal 0. But if the product of two quantities, if we multiply two things together to equal 0, what has to be true about those two quantities, x and y? So for us, well, I guess for anybody, they have to equal, one of them has to equal 0. Otherwise, it's not going to work. There's no way that we can make two numbers multiply with one of them not equal to 0. So we're going to come down here and we're going to write a property about that. So if two or more, so it could be more than two, but today we'll just look mostly at two. If two or more quantities have a product of 0, so when I multiply them, remember that's what product refers to, then one or more of the factors must equal 0. For example, if a times b equals 0, then a equals 0 or b equals 0. One of them has to equal 0. This is called the zero product property. And we are going to combine it with factoring in order to help us solve quadratic equations. So, for example, this one has already been factored. So I have this times this. So I have two quantities being multiplied that equals to 0. So if we use that zero product property that we just discovered or talked about, I guess we knew that it was true already. We just hadn't written it down as a property before. Either x minus 4 equals 0 or 2x minus 3 equals 0. One of those has to be 0 in order for this to be true, since it is equal to 0. So all we have to do is separate that into two different equations, solve each one. So on this one, I would just have to add 4 to each side of my equal sign. That goes to 0, and I get x equals 4. On this one, I have to add 3 to both sides of my equal sign. That goes to 0, and I have 2x equals 3. So to get rid of the 2, I have to divide, so that goes to 1, and I get x equals 3 halves. And those are my two answers. So, important part, it has to be equal to 0 first, and then we can just split up those factors into two different equations and solve that for our answers. So let's try that on the next example. This one we have to factor ourselves. It is equal to 0 already, so that's nice. We just have to factor the left side. So I need what times what gives me 9, adds together to be -10. And go ahead and pause this video at any time if you want to try the example first and then check your answer afterwards. So we can use the shortcut because we have a 1 up here as our a. So we can jump to x minus 1 because that's one of our magic numbers. And then x minus 9 because that's our other magic number. So now we're at the same spot that we started in example 1. So if this times this equals 0, then either x minus 1 equals 0 or x minus 9 equals 0. So then you just have to solve each of those and get x equals 1, solve this one, and we get x equals 9 as our two answers. Okay, go ahead and pause and try example 3. This time we have a GCF of x, so we can take out an x. We get x minus 7. Once we divide both of those by x, remember you can always check factoring. If I multiplied this back together, I would get what I started with. But again, it's the same thing. I have this times this equals 0. So if that's the case, either x has to equal 0 or x minus 7 has to equal 0. This one's already solved, so we have half of our answer. Then we solve this one, and we get our second answer. On the second page, or the back of the first page, if you have it back to back, we have steps for solving quadratic equations by factoring. So we didn't have to do these first two steps. It was already set up for us, but now we've got to practice this. So number one, we have to collect all terms on one side of the equation. It should always be equal to 0. And then we have to make sure it's written in this format with our x squared term first, and then the x, and then the constant. And then the rest is what we're used to. We factor, we separate it into different equations, set equal to 0, and then we solve those equations. So let's make sure on step 1 that everything's equal to 0 first. Step 2, that it's written in the right order, and then we can go from there. So example 4, step 1, it's equal to 0, check. Step 2, it's all in the right order. So we are ready to go, just like we were before. So again, this time we have another GCF. This time it has a number and a variable as part of the GCF, so 2x. Dividing by 2x, I have x plus 3 left over. So again, this times this equals 0, so either 2x equals 0 or x plus 3 equals 0. So this one we solve by dividing by 2. 0 divided by 2 still equals 0, so there's half of our answer. And here's the other half when we solve that one. Example 5. Okay, now this one is not equal to 0. So what I like to do as a rule is I like to keep my x squared term positive. It makes it easier for me to factor later on. And so I'm going to leave the x squared where it is because it's already positive. So that means I have to move this stuff on this side of the equation, which we only have one piece. So to change this into 0 or to turn this into 0, I have to do 1 minus 1. But it is an equal sign, it is an equation, so I do have to keep it balanced. So I do it to both sides. So now it's equal to 0. Combine like terms on this side. And we have x squared minus 9. So now step 2, we have to write it in the form of ax squared plus bx plus c. You don't necessarily have to do that. They are in order right now, but if it helps you to factor, go ahead and fill in that middle missing term with a 0x, if that helps you use your x in factoring. So what times what gives me negative 9 and adds together to be 0. So here we have a positive 3 and a negative 3, so that will help me with my factoring. And then I'm on to step 4, so breaking this up into two equations, either this equals 0 or this equals 0. Solve each one of those and you get x equals 3, and solve this one to get x equals negative 3. For example 6, same thing again. Step 1, we need this equal to 0. My x squared term is already positive, so I'm going to leave all of this on that side and then move this guy. So we would move him, get rid of negative 10, or make it equal to 0 by adding 10, but keep it balanced, so you have to do it to both sides. So this will go to 0, and now we have 2x squared plus 14x plus 20. And now we're ready to factor. So don't forget, the very first thing you should always look for in factoring is a greatest common factor, and this time we have a common factor of 2. Our greatest common factor is 2, so we take that out, or we undistribute it or divide it from everything. So this becomes 7x, this becomes 10, and again you can always check, did I do that right? If I multiply that 2 back in, will I get what I started with? And the answer is yes. And then we continue. So now we have the inside that we can factor using our x. So what times what gives me 10 and adds together to be 7. So then we factor using those two magic numbers, positive 2, positive 5. Now this time when we separate this into different equations, we do have 3 pieces now. I multiplied the 2 times this equals 0. So one of them has to equal 0. However, if I use the 2 and set that equal to 0, that doesn't make any sense at all because 2 can never equal 0. So I don't actually have to worry about that 2 because it does not have a variable. So I can just say either x plus 2 is going to equal 0 or x plus 5 equals 0, and those are the only two that need to be solved. And we get 2 answers. And most of the time for a quadratic, you will get 2 answers. For example, 7, x squared is negative, so this time we're going to be moving everything from this side over to the right. So how I move things, so it's a negative x squared, so then I'm going to add x squared. And I'm going to move the 100 at the same time, so that's going to go to 0. Minus 100, so I add 100 plus 100. That goes to 0 as well. So now I have 0 equals. And let's do step 2 right now. So I have to write all of these in standard form. So the x squared term goes first, and then the x term, and then the constant. And now I'm ready to factor. So what times what gives me 100, and you can list out a lot of things for that. But what ends up working is 20 times 5. However, they have to add together to be negative 25. So I have to make them both negative. So then that will help me factor. I can use the shortcut on this. And then I can set each of those equal to 0. Either that equals 0 or that equals 0. So x equals 20. And then on your assignment, you'll probably be asked to put it in the same box. So then you can just put a comma in between your 2 answers. Okay, on this one, same idea. My x squared term is positive, so I'm just going to add 1 to both sides of my equal sign. But this time, I do not have an a equal to 1. So you have to remember, when you are factoring, that 9 gets multiplied by 1 for your top number. 6 is still my middle number. So my 2 magic numbers for this will be 3 and 3, but we cannot jump to the final answer for this one. We have to break up that middle term. There's a different rules. So we break up this middle term into 3x and 3x, our 2 magic numbers. And then we factor by grouping. So we split this in half. Now that I have 4 terms, the GCF over here is 3x. The GCF over here is just 1. So I factor out a 3x and I get 3x plus 1. Factor out a 1 and I get 3x plus 1, which is great because I want the same things inside there. So there's the common factor. And then I take these 2 GCFs that I pulled out and they get their own set, their own factor. Okay. So now when I break this up, either 3x plus 1 equals 0 or 3x plus 1 equals 0, but they are the same thing. It'd be the same equation, so you don't have to write it out twice. So in this case, we only have one unique answer, and that's okay. Sometimes you only have one x-intercept. So next equation, or last equation. And then we have a word problem. On this one, x squared is positive, so I'm going to move this guy. Minus 11x on both sides. That goes to 0. So writing this in standard form, I have my x squared term first, then my x term, then my constant. Again, no GCF, and I have an a greater than 1, so I have to multiply those to get a negative 12 on top. Negative 11 on the bottom. So negative 12 and 1 are going to be my magic numbers. But again, we got to break this up in the middle. Break up the x term. And it doesn't matter which one of these you write first. You can put the 1 first or you can put the negative 12 first. But then we break it in half and factor by grouping, just like we did on the last problem. Oop, forgot the square. So my GCF here is 2x. My GCF here again is 1. So factoring out a 2x, I get x minus 6 left. Factoring out a 1, I also get x minus 6. Perfect. So now I factor out the x minus 6, and what I'm left with is my GCF here and here, 2x plus 1. Okay. So now I will have 2 unique equations, so either x minus 6 equals 0 or 2x plus 1 equals 0. So solve both of those, and you get 6 and negative 1/2. On the word problem, the length of a rectangle is 7 inches longer than it is wide. So I'm going to draw a picture. And we don't know a lot about it. We don't know how wide it is, but we know the length is 7 inches longer than the width. And if the area is, we do know the area is 120 square inches, what are the dimensions of the rectangle? So what are the length and the width? So we're going to set up an equation here. And the equation that we know is we know that area equals length times width. So let's fill in what we know. And really the only thing that we know at this point, like for sure, is that the area is 120. But now we have to fill something in for the length and width. And we know a relationship between them. So I'm going to pick the width over here to be represented by a variable x, because I don't know how long either the length or the width is. So it's going to be x on both sides. But if that is x, then we know that this side, which is going to be 7 inches longer, can be represented by x plus 7, because I'm just adding 7 inches on to create the length. So now I can fill this in as x plus 7 for my length and x for my width. And now we have an equation to solve. So let's go ahead and solve this. So let's get rid of our parentheses first. And now this should look like an equation that we've seen very similar ones previously on this page. So we got to get this equal to 0. So minus 120 from both sides. That goes to 0. X equals, 0, x squared plus 7x minus 20, minus 120. And this, it's okay if this takes you a long time. Just start listing all the things that equal 1 times 20, 122 times 60. I don't usually add my negatives in until later, but you keep going, 4, 5, 6. 6 times 20, 7, 8 times 15. I think that's the one that we need. So if we make it a negative 8, it is going to multiply to be negative 120 and add together to be our positive 7. Those are our magic numbers for in here. So let's factor using those magic numbers. X minus 8, x plus 15. So when we set each of these, x minus 8 equals 0 or x plus 15 equals 0, and solve those, we get x equals 8 and negative 15. But we have to remember that these answers right here for x are actually representing something, and we are trying to solve this problem. So the question is, what are the dimensions of the rectangle? So we have that x, which represents our width here, is either 8 or negative 15. And in this case, when we're talking about a real life situation, negative 15 does not mean anything. It doesn't make any sense to have negative 15 inches. So that is called an extraneous solution because it doesn't actually work for our original problem. So we can say that x equals 8 inches. So that's our width. And then our length would be 8 plus 7 instead of x plus 7. So that means our length is going to be 15 inches. So there we go. If you want to write that out separately, width equals 8 inches and length equals 15 inches.